So we have gathered some basic knowledge on the supervised learning. We have seen that there are two different type of supervised learning. We call it as classification and regression, and also we have seen some examples, and we went through some idea of what classification and regression is, different type of classification and regression is. Now we will start with what you call unsupervised learning. Okay, so what my now question is that why this unsupervised learning is required? We already have supervised learning, we have a data set, but in real world there are a lot of cases where vast majority of available data is unlabeled. What does it mean? It means that there is features, but the end result you don't know. What is the example for this? Okay, we'll go for example further. But unlabeled means that end level is not known. Okay, that means if a lot of houses, you have idea about the carpet area, the location, and many other features of houses, lot of houses, but you don't know what is their exact price. It's something like that. Okay, or maybe you have a lot of different mails coming from different people, but you don't have any idea that which particular mail is spam, which is not spam. So definitely it's not labeled. So in that case, how we can go for creating a machine learning model? So either there is, I mean, the very simplest approach is that manually label the dataset, right? But it is almost, you can say, an impossible task. How you know which particular dataset which is of which particular level, right? That is why we go for another type of technique of machine learning that we call unsupervised learning. So naturally, by the name you can understand the unsupervised means there is no supervision. So that means the learning without a teacher. So what is basically try to find out? You have a set of data. So if you have a data and if you plot the data on the on some axis, you will have lot of dots, right? Each and every dot represents the data itself, right? So that will create a pattern in the space, right? So the motivation for this unsupervised learning is to automatically identify some meaningful pattern in that dataset from the distribution. Okay, so how to do this? We'll come soon on that part. But before that, let's see what are the different type of unsupervised learning we have. So there are two different type of unsupervised learning we can have. One we call clustering, and another we can say dimension reduction. What is clustering? Clustering means identify similar instances with shared attribute in the dataset and group them together into cluster. What does it mean? For example, just assume that in your college or in some institute, lot of students are there. The students may come from different background, may come from different, say for example, places, or may come from different, say for example, different, uh, uh, you know, different marks and something like that. If you put the background or the different the place from where they came in the graph, you will see there are some people maybe come from Kolkata. There are some people which has come from, uh, say for example, Mumbai. There are some people come from Chennai or something like that. So naturally, the students which came from Kolkata will be very close to each other rather than the students which came from Mumbai, because their place is different, right? And this is what we can say, the students which are very close to each other can make a cluster. Cluster means they are together almost, you can say. So we will specify some radius. Within that radius, we can say all these points are very similar to each other. Now, on which basis I am saying? I am saying on the basis of their distance. Distance between each and every point. Okay. So, how this distance is calculated? There are a lot of different ways, and basically there is a lot of different algorithms for creating this cluster or identifying how many clusters are there. I'm not going to the algorithms right now, but what I'm trying to say, that what exactly clustering is. Okay. Anyway, we'll go in detail on this clustering part later. But now what comes this dimension reduction? Dimension reduction is something like you have a lot of features, right? Just assume a situation. I want to make a graph. Okay, I want to plot those data. You see that if you have a data set having only two features, okay, only one feature and one output. So what you can do? You can simply plot in a 2D space. One axis will represent the input feature, another axis will represent the output, not output feature, output, right? But if you have two features, okay, if you have two features and output, so naturally you require a 3D space, three-dimensional view, because two axes will represent, say x and y axis will represent the two features of every example, and corresponding z axis will represent what? Z axis will represent the output of that particular example, right? Now, if you think that for a particular example, you have some value of x for the first feature 1, you have some value of y for feature 2, and also you have some output which is represented in z, right? So if you put the value of x, y and z, you will basically get a point on this 3D space which is originated from the origin, which is basically your vector, right? So that means in this way, if I say that I have n number of features, that means you require n plus 1 dimension to represent that point in the space. So naturally, if this n plus 1 dimension is more than 3, you cannot draw on your copy. You cannot show that, right? But try to assume this, that you have a m dimensional feature. Sorry, n dimensional feature. It means that each and every dimension of that particular space is representing one feature, and the last dimension, the in last dimension of the n plus 1 is representing the output. Okay, now among these n dimension features, obviously all the features are not useful, that already you have seen. We can try to select some features, some we can in that case we can delete omit the other features, and from there actually this dimension reduction word came. So we're trying to reducing the dimension of the dataset. It means that basically we're trying to reduce the number of features of the dataset. So number of features is equal to number of dimension. As simple as that, you can assume in this way. Okay, so we have some technique over there. For example, principal component analysis is a very useful and very well known technique, algorithm obviously, which is used for reducing the dimension of a of a data set, but does not mean that reducing dimension does not mean that omitting some feature. It means something some different, but one you can say that is, say for example, you have 100 features in your data set and you will optimize it not to, say for example, 50. Instead of 100 you are using 50 features. Okay, now how this 50 features is selected, that is I'm not going to say right now about the dimension reduction algorithm. When we will discuss that, then I will show you. Anyway, so let's come back to the clustering part again. The clustering looks something like this. As I told you, that identify similar instances with shared attribute in the dataset and group them together into clusters. What does it mean? As I told you that we have a dataset which does not have any output. We don't know their level. For example, 750, 950, 650 all are the area and their prices is 50 lakh and something like this. Okay. Now see, these are, say for example, this is, say for example, a data set. Okay, a data set. I don't know what is their output. I'm not interested. Okay. But what I can do, I can create, I can plot each and every example on a 2D space. If I do this, what I will get for each and every area corresponding price, if I put 750 corresponding 50, I will get some dots, something like this. And you see, you will see that there are few dots which are very close to each other, few other dots very close to each other. So what you can do, we can try to make a group, something like this, and this group is for cluster. Maybe you can say that where these other points are, where this point will be, where this point will be, you can say these points, say for example, these are somehow missed, or say for example outlier in the data set. That is why these points somehow was not able to considered in either of this cluster. Maybe. Now question is that when these clusters will be useful. The cluster will be useful when I will go for trying to understand the pattern of these two new data. If my area is 700 and my price is 55 lakh, then under which cluster, which pattern it is following. So this rate point that you can see here is representing a new data. Okay. So naturally, this rate point is not present even with in this cluster, not in this cluster. So under which pattern I will consider? In this situation, the distance comes. A very important role it plays. What it says? It says that okay, let's calculate the distance between the center of this cluster with this point. Similarly, calculate the distance of center of this cluster with this point. Whoever distance is minimum, I will consider that particular point under that cluster. For example, assume the distance between pink cluster's center and this rate is lesser than the distance between, obviously you can see, distance between white cluster's center and this rate. So naturally I will assume that okay, this rate point is following a similar pattern of all these points present here within this cluster. Okay. Similarly, let's see what is the technique that we have some unlabeled data set. What do? We go for clustering. Clustering I've done like this. Then what do we do? Based on the clustering, we label the dataset. Because we consider, say, for example, this is level 1, say, not area or house price. Maybe it can be some email or something like that. Okay, content and it is the mail email content. Okay, and the another parameter can be, say, sender's address. You don't know which one is spam or not spam, so you can say that, okay, if it can be either of this pattern, and maybe somehow if you know the label of this particular set of this particular cluster, maybe you can say, okay, so label of this new data will be something like that. Okay, anyway, so we'll go for clustering, we'll label the data set, and then we go for supervised learning. So what this clustering is required for labeling the data set, so that we can apply supervised learning if required. Okay, so naturally, if supervised learning done, then we go for new data prediction. But remember, here this clustering plays a very vital role if we have unlabeled data. Okay, now just in a brief, if we talk about dimension reduction, it is something like in supervised learning there is a very big challenge to handle the large number of input features that I told you. For example, over here, if you have a picture and this is 1900 versus 1180, this is the number of pixels present in x and y axis. So total number of pixels will be in form of lakh. So if I consider each and every pixel is the feature, then it will be very difficult to train a model, because our model will train with 20 lakh, more than 20 lakh, 20 lakh, not 20 lakh, yes, 1000, yes, more than 20 lakh features is going to be very difficult. So what we can do, we can try to minimize this number of features from 20 lakh to, say, for example, 20,000 or some, maybe less than that. Okay, so here the dimension reduction come. Okay, so that's why what we do, that we have this original data set, we somehow apply some dimension reduction algorithm which basically minimize the data set in form of number of feature. Okay, then we apply some learning. Okay, so this is what you can say unsupervised learning is. Okay, now we will go for what are reinforcement learning